Okie dokie. So here we go. Week 24. We are doing some right triangle and circle applications. So for our first question, we have this. It looks like a circle, and there's this piece cut out, and it asks for the shaded area. So we are looking for the shaded area, and it is the area of this. Okay, so that's a sector minus the area of this, which is a triangle. So go back to what you know about right triangles, and we've been using SOHCAHTOA for a while. Remember the area for a triangle. Area is 1/2 base times height. And then for the area of a sector, we have 1/2 r squared times theta, where theta is in radians. So you might try to solve that and then continue viewing. So I sort of spelled this out in pictures. The area that we're looking for is the area of the sector minus the triangle. So for this sector, we have 1/2 times the radius squared, 2 squared. And then this right here, notice how there's a 120-degree angle. So 120 degrees in radians, we would multiply the 120 by the pi over 180. So this is an expression for the area of the sector. And then we're going to subtract the area of 2 of these. And these little guys look like this. So hopefully you recognized, 30, 60, 90, in which case the short side is half the hypotenuse, and the long side is √3 times the short side. So we have 2 of these where we're going to have, look right down here, 2 and 1/2 base. So I was calling this the base and this the height. So we could redraw that triangle like this, where our base is √3 and our height is 1. And so this is the area of one of them, and we multiply by 2 because there's 2 of those little triangles. So this simplifies down to 4 pi over 3 if you reduce and multiply and multiply. And this ends up being square root 3. So it looks like our area is 2.46-ish. Alright. Little geometry thrown in there. So area of sector minus triangle. Our second question for this says this. Alright. Hint, that looks like number 64. So there's a rain gutter. A rain gutter is to be constructed from a metal sheet of width 30 centimeters by bending up 1/3 of the sheet on each side to an angle theta. So here's our rain gutter, where we have 10 centimeters, 10 centimeters, 10 centimeters, and we're bending up these sides so they could get steeper, and we could have a rectangular rain gutter, or it could be like this, or we could have it out at 45 degrees. You've seen rain gutters before. So what are we supposed to do? First, show that this basically means derive, alright? Show that the cross-sectional area of the gutter is modeled by the function so-and-so. So, show, meaning, cross-sectional area. Here's a 3D view of the rain gutter. Alright, like that. Here's your house. By cross-sectional area, we mean if we were to just chop it like this, we'd be looking at this, the cross-sectional area. So this right here, this is our cross-sectional area. And that area, this is a trapezoid, but I like to think triangle plus rectangle plus triangle, where each of these little side triangles looks like this. So if you were to SOHCAHTOA this thing, where we said, here's our, let's see, is that our angle theta? Yep. Here's our angle theta. We could say that the adjacent over the hypotenuse is equal to the cosine of theta, and after solving we would get that this side is 10 times cosine theta. Similarly, after solving for the length of this side, we would get 10 times the sine of theta. So if we use that information, take a look here. I basically filled in the lengths, filled in the lengths, and filled in the lengths. So when we talk about that area, we're going to have 1/2 base times height, and that's for this, plus length times width, or length times width. So plus 10 times 10, I'm just going to go 100, and then sine theta, plus, and then the area of this, which is again 1/2 10 cos theta 10 sine theta. I'm going to write over the instructions. Theta. So if we combine these, we have half of this and half of this makes a whole of this. And 10 times 10 is 100. So we have 100 cos theta sine theta plus, over here, 100 sine theta. And that is our expression for, hey, whoa, okay, that got super messy. Whoa, hey, let's just pretend that didn't happen. Oh, great. Oh, great. Help. Okay, whatever. And so this is the expression as a function of the angle, which is what it was asking us to do. Show that, and so those expressions are equivalent. Part B, graph the function that we just created for, or between, so these are our x values, or theta values, right? We could think of this as x, x as well. Between 0 and pi over 2, so you should try that. Get your Desmos out, type this in, and you could type it in as y 100 cosine of x sine of x plus 100 times sine of x. Make sure that it is in radians and go to the little wrench thing in the top right corner and set the x-axis, the scale to pi. We'll see. So where is that diagram? Oh yeah. And then lastly, let's just read this question because I'm going to turn the page. For what angle theta is the largest cross-sectional area achieved? So if we're trying to, if we want the gutter to hold the maximum that it can, what angle should we choose? It's obviously not 0, then it'd be completely flat. Maybe it's 90, and then it would be a rectangle. So let's turn and look at our Desmos. So here's how I typed in the equation. And then over in the little wrench thingy, well, we can't see it. But anyway, in the wrench, I made sure that the divisions on the x-axis were in terms of pi, and I set the scale so that, here, this looks pretty good. So we go from 0 to pi over 2 here, like this. And it looks like our maximum value, which we're interested in, so it looks like we get to an area of 130, whatever that is, probably square centimeters. And then that takes place at an angle of pi over 3. So our graph should look something like that. So you should label, label your area. We went up to a value of 130, so you should write that in there. And then on the x-axis, over here we had pi over 2, and then pi over 3 was somewhere here, and the graph looks something like that. So make sure that you write that in. And so to answer our question, we have that graph, and then the maximum area occurs when theta is pi over 3, which that's about, exactly 60 degrees. So it would look something like that. And you know what? My experience with rain gutters says that that's about what they look like, where this is 60 degrees. Cool.